Hey Ravens, today we're going to be talking about the calculation of rate of reaction of an enzyme. So first let's talk about what is rate of reaction. So the rate of reaction is how fast an enzyme can do its job. In this case for the lactase lab, we're measuring how fast lactase, which is the enzyme, can break down lactose. And lactose can be found in any dairy products like ice cream, milk, in our coffee, in our creamers. It's anything that has dairy in it. And lactose is a very complex carbohydrate. And the job for lactase, the enzyme, is to break down that protein into, or that, sorry, that carbohydrate, break down that carbohydrate of lactose into glucose, the simplest form, right? So the first things first, within this lab activity, you'll learn about, you can hear a little bit more about enzymes and everything. And we're actually going to open up this lactase enzyme lab activity. And it'll take you to the screen. So a little bit intro. You have some intro questions, so you can find the information for that on the home tab, the background tab, and you can even click on this explore model a little bit to look at what the model is looking like. But here you have the initial lactose, the lactose concentration. So this is like the amount of dairy or that or milk within this activity, but it's measured out to just lactose itself. Then we have the temperature where we can modify the temperature, and then we have the pH as well, and then whether lactase, the enzyme, is present or not. But for this experiment, we're actually going to we're going to be changing around, for this part of this experiment, we're going to be changing around the temperature. But first, let's actually look at the how to calculate rate of reaction. All right, so this is the actual legit formula for it. It looks a little bit intimidating, but let's break it down. So the rate of reaction, I've just equaled it. I just had it represent as R equals delta, the concentration of your substrate, and delta, or divided by the delta time. And anytime you see delta, which is pretty much like a triangle, it means the change of. So you're subtracting the amount that you finished at the end of experiment from the amount that you had at the beginning. So we can break it down a little bit better and spell it out. So if we look at the rate of reaction equals the change in concentration of glucose over the change in time. Let's go down a little bit further. So you have the rate of reaction equals final concentration of glucose minus the start concentration of glucose divided by the change in time. So we're gonna keep the amount of lactose the same at 50 milligrams. There you go. And we're gonna keep the pH the same at the pH of 7 is the same. We're just gonna play around with 0 degrees, 20 degrees, and 40 degrees. Now, what's different in this chart than this chart that you have for your activity is that it only asks the rate of reaction. So when you go to do the reaction itself through the simulation, I would draw out a chart or make a chart similar to this. All right, so this column right here talks about the final concentration of glucose, the starting concentration of glucose, and then we'll calculate out the rate of reaction. All right, so. And of course, the starting concentration of glucose at this time is always going to be 0 for this experiment. All right, so we'll put that in there. And so let's do 0 degrees first, Celsius first, and then we are going to click on run the experiment. So over the time of 20 minutes, our start time was 20 minutes, or it was 0 minutes. We let it run for 20. And the cool thing about this, say like in this line, there was no change. So you have 0 glucose. So let's go into our chart and you have 0 glucose. So what this is going to look like, and we'll click that draw tool, and what this is going to look like for trial 1 for 0 degrees Celsius. And I'm just going to write it over here. So what the formula is going to look like, we're just going to do 0 degrees is equals, and you have 0 for the concentration of, so we'll put like 0 for, we'll put 0F for final. minus 0s for start divided by, and we already know the time length, right? So it's going to be 20 minutes. All right. So if I go to my handy dandy, oh, I think that's pretty good. If I go to my calculator and I do 0 divided by 20, I get 0. So nothing, my rate of reaction for that is 0 because it never happened. And we're measuring our rate of reaction in milligrams per deciliter. Actually, it's deciliter, my bad. Per minute. All right. And this is the rate of reaction to produce glucose. Now let's go back and we're going to restart this. And we're going to hit restart or reset. And let's change our temperature to 20. And you can actually just type over instead of dealing with the scrolling. So we're going to start at 20. So our starting concentration is 0. And then let's hit run. All right. So we're done after 20 minutes. And the cool thing about this is you can actually click right here and it will show you what that value is. So we're going to do 479, right? Over 0. So then for this one, we're going to do, let's do 20 degrees. And we're going to set up that formula equals, and we're just going to go ahead and just say 479 because we know 479 is the final concentration of glucose. And we know that starting was 0. So we're going to 479 divided by 20 because that was the amount of time. So let's look at our calculator. Let's do 479 divided by 20. And so it is 23.95. So our rate of reaction, and remember if you need to go back to typing, you'll come up here. We started off with as a pen. If you make a mistake, you can use the eraser. To erase, just click where you need to. So here I'll erase that little dot right there. Or if you need to go back to typing, go back right there. So our reaction is 20, what is it? What did we say it was? 23.95. Yep, 23.95 milligrams per deciliter per minute. All right, and let's do the same for 40. All right, so we're going to hit reset. And actually, guys, if you want to, you can even play around with it, and it will show you the different. So we'll run that for 0. We'll run it for 20, right? And then we can also run it for 40. And let's run it for 40. All right. So here we go. Let's go to our measurement, right? So our run for 40, if you click on anywhere on the graph, actually, if you just measure it over here to the 20, it will show you that it is 494 for that. So we'll put 494, and then we'll do the math, and let's do that math real quick. 494 divided by 20 minutes. 494 divided by 20. We'll enter, so it's going to be 24.7. 24.7, so not a huge difference. Oops, sorry, let's make sure we're back over here. 24.7, it's not a huge difference with just that 20 degree Celsius change. But then we can even go, and you can kind of just play around with the numbers real quick. And let's see what is it going to look like for 60. And you can play around with it a little bit. And then let's look at 60, right? So not so good, but you can try it out with yourself. So then for each temperature, you're going to run the trial 5 different times to get a number. So what's really nice is that for 0, let's do 0 degree for this one. You can hit run 1, run 2, run 3, run 4, and then run 5. So it does all 5 runs for you. And you can just slide it over real quick, slide over your value, and it gives you the values down here underneath the chart. So like right here for you. And you do the same. So then you'll increase to 20, but you can calculate the rate of change for 0, put that in, and then find the mean. Now, the mean is another way of saying average. Yep. But we'll discuss this. This is just a reminder video on how to calculate rate of reaction. Hopefully you found it informative. And of course, as always, you know my email. It's robert.clifton@mmps.org. Or if you're on Schoology, hit me up with any questions you have about calculating the rate of reaction for this lactase lab. Thanks for watching.